the success of Tomlinson is built on its people.
Construction industry is very much a family.
Smoother, better, it's more client friendly, it's easier, more productive.
Like, I think just people hear the name Tomlinson, they know what has gotten around of what kind of a company we are, what we offer.
If you look around the city, the name Tomlinson, it's a kind of a testament to that.
All right, so here today we have an episode with Ryan Andre, our local concrete expert here at Tomlinson Group. Ryan, maybe just tell me a little bit about yourself and we'll get going.
Yeah, my name's Ryan Andre. I'm the quality control manager here at Tomlinson Ready Mix. I've been with Tomlinson Group going on 18 years now. My background is in concrete, so I used to do form work and quality control work. Once we purchased Tomlinson Ready Mix, I became the QC manager, and I've been in that department since, kind of troubleshooting for customers, developing mix designs, trying to keep us, on top of what we're doing. And yeah, that's basically my professional background has been in construction and always ready mix concrete related. That's been my background in construction.
And I guess you've grown a passion for the product. As almost everybody in this office knows, you're a pretty big advocate for concrete. So
yes.
Maybe just, why?
Yeah. So yeah, I am passionate about concrete. My family's in it. My father was in concrete, my brother's in concrete, my wife's in construction. So looking at concrete as a material, it is the building material of choice of the 20th century, and it's going to maintain the building material of choice of the 21st century. There is no part of construction or our modern world that isn't touched by concrete. Everything we have in our modern cities is brought to you by concrete. Underground infrastructure, roads, curbs, sidewalks, structural buildings from your house foundation up to 40, 50, 60-story buildings. Concrete is our building material of choice. There's no other material that's as malleable or, consistent architectural than this product. And that would probably be why I'm an advocate of it. We use so much of it in our modern world in construction that it's just a requirement. It's a requirement for our civil. We use it for durability.
It's the second most used product in the world after water,
it's the most
right?
used
construction
material. There's no equal. So, I'm passionate about it because it matters. It matters to us in our society. It matters to our Canadians. It matters to the world, really. How we build with concrete builds our surrounds. So that's why I'm passionate about it. I enjoy it. I like to see what's new coming out. And I like to see where it's been. I like to see the past. I like to see the projects we've done or that we've seen in the past. It's an interesting material. It's very noticed what you can see, and there's a lot underground that we never see.
Yeah, so this is an interesting podcast for me, right? It's with Ryan. We work together every day. So, and like your last comment, really, that's the one that hits home the most for me is when you're driving around and, hey, we built that thing 15 years ago, 13 years ago, whatever it may be. And, people are using it. They're using the hospital. They're using the school. They're using whatever public infrastructure that we've built, or you're driving across a bridge, or heck, you're walking on the sidewalk that's, on the corner of Woodruff and Fallowfield or whatever it is. It's kind of, you leave traces all along the way, and you're just a small part of actually that specific pour, but the group did it, right? And it's interesting to know that you had to played a part in it.
Yeah,
basically.
That's right.
We get into the building material of choice. One of the key components, I guess, is like just the durability, and with durability means your life cycle of your products a lot longer, and you get into talks about sustainability, which we're as an industry, concrete's always preached it in a means where if you do something, well, it's there for decades. Yes. Not 5 or 6 years. We're talking 20, 30, 40, 50 years. And now we're getting into buildings that are 80, 100 years lifespan. So talk to me about that.
Yeah, I think concrete has always been chosen as a material of choice with construction due to its life cycle, due to its durability, due to its sustainability in the field. It's a local material, which is helpful. So our cement product, the binder in the mix is close. Our stone, our sand, our water, and modern admixtures, they're all within 400 kilometers or less. So it's a locally sourced material, which is excellent. You can basically build concrete anywhere. And in doing so, as an industry, for a long time, sustainability has been number one. We've always looked at ways to become more sustainable. Through admixture design, we're using less cement now than we used in the past. Efficiency of aggregates, just overall understanding of how our concrete is used in the field, we have become a more sustainable product with time. And as we are in the 21st century now of construction, and I want to say it's been since the early 2000s, sustainability has been the prime directive for our industry, and low carbon is probably the number one, focus that we're focusing on right now. And that comes from the cement industry through the ready mix industry and goes to the construction industry, and end result being the owners, the buildings, that type of thing. So low carbon intensity, low carbon embodied concrete is what people are looking for. And that's our number one sustainability now that we're working on. But sustainability has been a big part of our product and our industry for a long time.
So how do we achieve, what are we doing different to get low carbon concrete?
Yeah, so when it comes to standard or old fashioned concrete, we made use of Portland cement. So cement, that comes from a high intensity or a carbon intensive process where you're basically crushing aggregates and then you're feeding the aggregates through a hot, energy intensive kiln. You're then taking this clinker is what it's called, and you're then crushing it down and running it through mills and to create a powder that is then reactive through the hydration process as soon as water hits it. That's an extremely carbon intensive process. And in doing so, cement has kind of been a target for the industry to lower it because it's a big part of our carbon intensity in the built world. So our industry, starting with cement, has looked at ways to make the cement production more efficient. So we've gone to a limestone cement. So that's a 15% replacement of Portland cement with a limestone filler, if you will, so a ground limestone. So that's not going through the kiln process. So there's less energy involved in that. So we're getting immediately some savings on our carbon intensity. From that, our industry, looking at ways to be sustainable for a long time, far before this carbon intensity, we've been using supplementary cementing materials, and we get these from byproducts of other industries. So slag cement's the number one supplementary cementing material in Ontario, and that comes from our steel industry. It's a byproduct of the steel. That's a waste product for that industry that becomes a bonus or a value-added product for our concrete industry. In the past, the coal-fired plants, they had fly ash. That's a value-added product for ready mix, and through the silica fume is another industrial byproduct that we grind up and make use of in our concrete as well. So all these waste products from another industry are now being incorporated into our concrete, so we don't have to use as much Portland cement, that energy intensive. We're now using a waste product, and in doing so, we're actually making more sustainable concrete, higher quality concrete by blending these materials together. And that's really where we're lowering our carbon intensity now. That's our focus as an industry, just lowering our overall cement, lowering our virgin cement, if you will, and we're making use of these supplementary cementing materials. And that's the industry's target. That's Canada's target. That's North America's target. That's the world's target, is to minimize our intensity on our Portland cement and maximize our supplementary cementing materials, amongst other things, to lower that embodied carbon.
And initially when we did that, it was all, there was an economics perspective to these fly ashes and these slags, right? And they were cheaper. So it was driving innovation in a way for us to actually understand how these products work. We weren't necessarily only using them as filler and as cost savings. The industry found out that there's performance benefits to these products. And as that happened, I'm going to say your capability of doing more performant concretes came out, more durable concretes came out, and then became part of specifications. And now these products are at a premium compared to where they were before, but they're certainly gaining more momentum on the pricing side than they did, which is interesting because it's a product that came from waste, and now suddenly there's large value to it, right? But we need it just like everybody else to lower our carbon footprint. And who knows what the future holds with those things, but there's people looking into, it's not just those two now, because there's a demand now and there's a price point behind it. there's investments being done to look at other products, right? There's glass and calcine clays and things like that. It's
exactly like, so because this is such a value added product now for the entire concrete and cement industry, these sources that we're getting from industrial waste, if you will, from these other, they're in such high demand that there's a limit to the waste that's being generated and a max that we as an industry can use. So that's driving more innovation to find other streams of materials, cementitious materials, what have you, to create this hydration process, to create this concrete. Furthermore, these industries, they're looking to lower their carbon intensity as well. So, in Ontario and Quebec, the coal-fired plants have all but disappeared. I think they've completely disappeared. So that source of fly ash, which was a waste, has more or less disappeared. We will get our fly ash sources from the United States. Well, the United States wants their fly ash sources as well to make their concrete greener. So our primary source right now is the steel industry, because that's Ontario, down Hamilton way. There's a lot of steel. That's where we get a lot of our slag cement, our SCMs. But again, as we are pushing for a low carbon concrete, we're going to probably see those materials either become a real premium, or just it's going to produce innovation. We're going to see other materials, other calcine clays, metakaolin, these types of materials will start to make their way into the market as value added cementitious. That's going to lower our Portland cement, our virgin Portland cement use, and that'll help us. That'll help the industry over time to become greener.
And how do we know what we're doing is right? Like, how are we measuring this? I know there was a large process that happened at Concrete Ontario almost a decade ago, I guess it started, just to measure industry averages with regards to our global warming potential or our CO2 content of our mixes and things like that. And then it seems like we're almost benchmarking off of that to know where each one of our, over 1,000 mixes now fall within certain categories and how much better we're doing compared to that industry average. Like you were part of that from an association level, and then you kind of brought that back here and brought your knowledge back here and built up what we're doing at Tomlinson Ready Mix today. Yeah,
that's right. So when it comes to sustainability, as mentioned, the industry, we've been making use of these supplementary cementing materials, these SCMs, for a long time. We always did put them in our mixes, but there was no way of quantifying just how green we're getting. We're putting in 25% slag replacement. That's greener than 100% Portland cement. But, the industry for a while, we have to now quantify that. And so back, like you say, it's probably over 10 years ago now, the industry, from the cement industry down, we started looking at environmental product declarations, or EPDs, as a way of measuring the carbon intensity or the inputs within our cements and our concrete.
And that's like your food label for your building material.
Yeah, that's right. Exactly. So these environmental product declarations, they give us the inputs, the energy inputs, your calories in your mix design, that it's third party verified from the industry. In our case, we looked at ASTM. So what we're trying to do in these environmental product declarations, in these EPDs, there's a lot of measurements that we're looking at from a sustainability perspective. The number one that we're looking at right now is the global warming potential, or the GWP. And what we're trying to do is lower that global warming potential per cubic meter. So our GWP is measured in kilograms of CO2 per cubic meter, or kilograms of CO2 equivalent per cubic meter. And the way that measurement is made up is through all of our inputs. So as an industry, from the industry down, from the association down, right to Tomlinson Ready Mix, we have taken on finding all of our inputs in Ready Mix, finding out how energy intensive those inputs are, the distance to plant, our production, how energy intensive our production is, how much natural gas we're using, how much fuel we're using in our trucks, how much does it take to make that 1 cubic meter of concrete. And in doing so, over the past number of years, through a few different industry-wide benchmarks that we did at the Canadian Ready Mix Association and the Ontario Ready Mix Association, or Concrete Ontario, we've come up with benchmarks, or industry-wide benchmarks. And in our latest one that was published in 2022, we basically did a benchmark of our 20 MPa concrete right up to our 60 MPa concrete, both non-air and air entrained. And there's a number of industry average global warming potentials that are built out. And what we want to do as a supplier is we want to achieve the same as the Ontario industry average or better. And so what we did, Tomlinson Ready Mix, we actually got our plants EPD Type 3 or Environmental Product Declaration Type 3, which is third-party verified. Again, going back
for the specific facility.
For the specific facility.
Specific mix.
Specific mix. And what we've done is we've got these third-party declarations. These are published on the ASTM website. So they are verified by ASTM, and we can tell you exactly how much carbon intensity we're going to make in that meter of concrete from our cradle to the gate. So basically the embodied carbon of that concrete to produce right to our gate as we're about to leave. And that's what we're really targeting. It's scope 1 or scope 1 to 3, or that's what we're trying to target and give some information to our owners and customers out there to find out what's the intensity and, you know, the advantage of it. It's not just us saying this is how green we are. It's third-party verified and can be back-checked through the ASTM website or what have you that way.
So then owners and general contractors up to, you know, depending on which projects they're working on, they're trying to get the same type of benchmark, if you will, for their projects. Like, I don't even think they have that yet, right? They're trying to model all that together with various products to get this building has an embodied carbon of X.
Yeah.
So that they can focus on reductions and things like that. So like information from all various products, we're starting to see steel, I think, came on board a little bit a couple of years ago, and who knows when wood's coming on board, or, you know, drywall and all those things I haven't necessarily followed. But the idea is to lower the carbon intensity of their project. And right now we must be getting a lot of questions with regards to how do they achieve their goals when it relates specifically to concrete, right?
Yeah. So what we're seeing, so for those that don't know, December 31st, 2022, the federal government put into effect basically a decarbonization of their buildings. So in doing so, their procurement plan now is to get a 10% reduction from the industry-wide baseline. So our Ontario published environmental product declarations, the federal government is looking for a 10% reduction from that. So in a lot of these federal projects, they're looking for a reduction in carbon intensity. And the number one material, as you mentioned, is concrete. We're the only ones that have really set up the stepping stones, the fully transparent, way of finding our carbon intensity. The other products are coming online like steel, and we'll see some other ones in the building. But at least right now, because concrete is a carbon intensive product, that's the one that they're focusing on at the federal government level. And that's the one what we're starting to see in projects in the field. So as that trickles down since 2022, when the industry published, when Concrete Ontario published the industry-wide averages, Tomlinson Ready Mix, we got our Type 3 EPDs at the end of 2022, so we were ready. We've seen a real uptick in requirement of it, and that's a trickle-down effect. It comes from the federal government. It's going down through projects. We're starting to see it at hospitals. We're seeing it at municipal projects where they're looking for either an overall carbon reduction in their construction, or they're looking at a mix-by-mix reduction. And in doing so, we're providing the customers value.
So what's the difference between those two options? Like, which one should they choose?
As an industry, we're looking to target carbon budget for an overall project. The idea being is that there are certain elements that you're pouring in a project that we can make quite a bit greener versus other elements that we may want to make less green. If we're building in construction between January and March, it's quite cold. We don't want a product that might be too slow, which is a byproduct of low carbon concrete. There's a lot of supplements going in. Those reactions don't happen as fast. And because of that, there's a little more risk in the built environment. So what we try and say or suggest as an industry is do an overall carbon budget at the start of the project. We can come up with a plan of how much reduction you want to make on your carbon intensity in your entire build when it relates to concrete. And our supplier and the contractor, and perhaps with the concrete finishers, the forming supplier, or the forming customer, we can all look at best ways to make that end target for each individual element. So that might be in the footings, high sustainability, where we're really putting a lot of supplementary cementing materials in, really lowering that carbon footprint, but perhaps for floor slabs, a little less greening of the mix so that they can turn around their slabs in a relatively normal schedule, especially when it comes to winter. And in doing so, you can kind of pre-plan the project beforehand where your carbon intensity is going to take place, where your less carbon mixes are going to take place, and you make an overall carbon budget to hit those targets. That's the ideal way to do it because it gives a little more performance-based and options for the customer, the owner, the supplier.
Everybody's needs are kind of listened to basically instead of being dictated by specifiers, right?
Exactly. And it's a more collaborative approach where we're not putting the green initiative ahead of perhaps the risk of the project of pouring floor slabs with 50% slag, which will take a long time in the middle of January to set, and there's a lot of structural risk.
Yeah, and then they need to heat.
House heat, and you offset a lot of your carbon.
Are they really ahead if they're heating with propane heaters?
That's right.
Like
and that's probably our number one way to do it as an industry. But as this has taken place, we're starting to see it on a mix by mix. Some they'll look at the items or the potential mix for an item, and they'll have the industry average, and they'll give us a target of what we want to hit for the global warming potential. And we'll make use of that, and we're doing that right now at a municipal project. We're building some ice, like a community rink,
sports
dome, and on a mix by mix level, we're achieving what the consultant has looked for greening. And in that case, what we're doing is we're working right away with our customer, our contractor, our finishers to ensure that they understand potentially building risks in January to March, these colder months of having these high supplements in these mixes. A little more housing and heating and protection might have to go into play beforehand. It's a collaborative approach. We're looking at it beforehand. You don't just wait till the day of the pour. There has to be a lot more meetings.
That's like I think where I was going, right? A lot of it, when we think of concrete, we'd price a project, you'd kind of get the job, and then you'd be radio silence for a couple of months, and then suddenly you get a request for mix designs. Send those in and start pouring a week after. That's how things were.
Yeah.
And now we're getting involved in projects at a much sooner date, which allows everybody to be a little bit more on the same page and finding efficiencies in what they do. And I think basics of it, we wanted to be involved in these projects at an earlier stage. This has made this happen, allow us to talk about other things, right? Whether it be set times that they require for certain projects. And I think makes the project more efficient and better chance of success too.
Yeah, that's right. And like you said, it is almost a dream. We would love to be at the forefront of bidding for all projects.
Yeah, exactly.
I think there's a lot of value that your concrete supplier can bring to you as an owner, as a contractor, and as the other subcontractors on the job site. There's a lot of a value that we can bring to you ahead of time, so we're not 11th hour figuring out mixes and problems with schedule. And this type of scenario, it's all about talking beforehand, so we can kind of come up with a plan beforehand. That might happen even before bidding, so that there's kind of a plan built out. And then you do your bid, and then you constantly monitor the project as it's going to ensure we're meeting our sustainability goals.
So how does this product change the life for our drivers or concrete delivery professionals or staff or end users?
Yeah.
So there's some tweaks there. Obviously, it's different, right? It's a different product.
So up front, if you were to just visually look at the mix, you're probably not going to see any difference. From a performance perspective, we're supposed to meet the same strengths, water cement ratios. There's a lot that is very similar. But how this mix differs in general is as we add these supplementary cementing materials, the greening of our mix, the sustainability of our mix, a different reaction or hydration process is going on. And it is typically slower. It's not faster because there's the original water and Portland cement reaction, that hydration happens. And then the offshoot chemicals, the unused chemicals, now are reacting with our supplementary cementing materials. And depending on the dosages we've put in, that can be delayed longer over time. So instead of happening in the first 6 to 24 hours of a normal hydration reaction, these might start happening after 24 hours, after 2 days, 3 days, 4 days, another reaction takes over. And that can mean slower set times for the finishers and the contractor. That can be more risk when it comes to winter, where housing and heating is more important because we're not going to get that same heat of hydration in our mixes. And that might mean just more scheduling and planning before you're backfilling, before you're stripping, and all that's involved. And for us as a supplier, I always say it's easy for us to make a mix. We can make any mix we want. We can make it as green as you want, but it does still have to be built. Yes. And there is structural concerns from an engineering perspective, from a safety perspective, from these guys working in the field. We still want this concrete to set in an efficient manner on time so that they can maintain some sort of schedule and the economics of the build. And, for our drivers, what's really important is to just understand the mix may look the same, but it may not hydrate as fast, leaving the yard. These guys have been, working in an industry with a fairly, consistent product over time. They understand when they leave the plant, they get to the job, how much hydration will happen, how much slump loss, the workability of the mix will be lost. Well, with these high supplementary mixes, sometimes there's not as much loss in slump. So we have to train our drivers a lot more to understand what's going on. Us as Tomlinson Ready Mix, we've actually built an Enviro product line to help our drivers and our customers understand when they're truly buying a low carbon concrete mix. We use this E-line to kind of show the amount of supplements that are in the mix. And that allows our drivers and our customers and anybody else down the line to understand this mix needs a little more care, a little more TLC before we go to the job. And our QC team on top of that is usually out there supporting the drivers, supporting the customer, supporting the owner in the end to ensure they're getting still the absolute best performance, probably improved performance and improved durability over time, but we just have to make sure everything's put in place beforehand. And being in Canada, being in Ontario, being in Ottawa, the nation's capital, this is a cold market. We really have to basically watch from around November to March, April probably, that this can really slow down and there's a lot more risk. Our summer season is quite hot. There's not, things are hydrating faster. But the winter, we're trying to scale everybody up to understand that as we start to build in 2025 and moving forward, this is going to be a reality, and we all have to kind of understand where the industry's going.
For it, right?
Be ready
we're
for it.
Starting to see a handful of projects, and we're probably going to get
reach out to us.
Dozens of projects, but we're willing to get involved early on to help the consultants, the specifiers, the owners understand what they want. Yeah. Because I sometimes I think they're just trying to do the best they can. They only have the information they have, but reach out. We can do lunch and learns. We can just talk to your people and get everybody at least understanding, get them more information, right?
That's right.
So with that, I guess, is there any other parting message that you'd like to pass on to the group?
As we move to sustainability, concrete's still going to be the primary choice. It's structural design. You can build anything from underground, outside, interior, multi-level. It's still going to be our material of choice moving forward. There is no parallel of material for its durability, strength, time. And as we increase the sustainability, these mixes tend to increase with durability and life cycle with time. So as we make them greener, they actually last longer. They become more durable. They're less pervious. There's less ingress of water. They're more impermeable. So it's excellent for bridges and exterior civil construction. And it just makes a better overall product. So the reality is it's not going anywhere. There's other materials. There's only one champion when it comes to building, and it's concrete. It's not going anywhere for the foreseeable future because it's a locally sourced, sustainable material. Concrete is 100% recyclable. So, it's not going anywhere, and people really should make use of more concrete in their building design. If you want true life cycle durability, there's no other material.
Yeah, it's like buying the good fridge, say a fridge, right? Yeah. And buying the good fridge and replacing it in 30, 40 years, or buying the cheapo one from unknown Temu or whatever it is, and replacing it every 2 years.
Yeah.
What would you rather
further
have,
ahead?
right? Or actually further ahead, not buying the Cadillac right out of the gate. So.
Yeah, that's right. And I think that's what our industry has been doing for a while now. We're trying to make people understand that it's a total life cycle. If we want to really be sustainable, we have to look at the entire life of a project, a building, a structure. And there is no greater material than concrete. It will give you the durability over time. with 100% recyclability at perhaps end of life of that, you know, and end of life for these products that we are building, we won't be here. We will be gone before these buildings are ever at end of life. So, and that's important to know. So,
Well, Ryan, thanks a lot for coming in. Your passion showed through as always when you talk about concrete, and have a good rest of your day. Thanks a lot. Take care.
Thanks.